So hey everyone, let's continue the MCP playlist. In the last video, I talked about introduction of the MCP and life cycle plus architecture. In this one, we'll talk about how we can build a MCP client, which is command line based, to connect to MCP servers, which are either running remotely or locally, call their tools, list their tools, fetch the resources, get the prompts, and also build an agent on top of this client, which can use this client to connect with the server and fetch the external data to supply it to LLM. So in this architecture, there are four main components of this CLI client. First is the command line that basically acts like a user interface for the user. It can take the CLI commands like list tool, call tool, or get resources, and then it will supply these commands to the parser layer. So the second layer is MCP CLI layer, which has parsers in it, command parsers. So they take the commands from the command line layer and they parse those commands to prepare input for tool calls, resources calls, or prompt calls. They also do certain additional thing like loading the config or profiles JSON. So this JSON contains the information about the MCP servers, like the MCP server URL, what are the input arguments that are required to connect with the server. Is there any authentication required? So all those details are present in this profiles JSON. So it loads that JSON along with parsing the commands which are coming from the CLI layer. Then also it handles the authentication. So there are all like most of the MCP servers has authentication required to connect with them. So all the API keys required or tokens, those are handled by this CLI component. When we do the connect command, when we try to initially connect with the server, it uses this authentication module to basically use the token that we have provided or API key that we have provided, or else it can do OAuth as well. So after doing that, it will store those tokens or access keys in the sessions data using keychain, so that user don't have to re-authenticate every time when it's talking to the MCP server in the same session. So this handles the session management of authentication, plus also it loads the MCP servers data which is present in the JSON file. Along with that, it also parses the tools commands which are coming from the CLI layer. It prepares them to supply it to next layer, which is our core MCP layer. So MCP is the third component of this architecture, and this is the core component which directly talks to the server. It has functions to list the tools, call the tools, or fetch the prompts, resources. It takes command inputs from the parser MCP parser layer, and then it executes those commands directly on the server using the MCP protocol. To do so, it also needs the client object, the transport client object, which can be used to make the connections with the MCP server and then execute the tool calls. So to create those client, it uses a transport file, and this transport layer creates two kinds of clients. One is HTTP streamable client, which is for remote MCP servers, and second is STDIO client, which is for local MCP servers. Uh, to talk with those MCP servers, it uses standard input output pipes in your local machine process. So this is about the architecture, and yeah, the last part of this architecture is the actual MCP servers. So these MCP servers can be remote or local, but to make connections with those servers, we have a JSON file called mcp servers.json. That JSON contains one object for each of the servers that we want to connect with. That object will contain the MCP URL. It will contain the any authentication or header that is required to connect with that MCP. So all this information is inside the MCP JSON file. That JSON file is utilized by this CLI client to make the connection or understand the server connection details. I'll show that when I jump onto the code. So with that, let's jump onto the code part and run the CLI. Let's do some hands-on.